Alright, so let's look at this problem. First decision we should make is probably relates to our differential area that we want to choose. Now it wants to find the location in the y direction. By the way, what would be the x centroid, the value for the x centroid? It's a parabola, right? So it's probably going to be x is equal to 0. So we could probably do it either way, but I think, as a starter, that we should choose a vertical strip. Okay? So it's going to be dx wide, and it's going to be y tall. Right? So that makes it pretty straightforward that our differential area will be y times dx, and y is given as 1 minus x squared over 4 dx. So there's our differential area all in x. Now what is the distance to the centroid? There's our rectangle. So what's the distance in the x direction? Our little tilde. It would just be x, right? That's it. So if I want to find the area, I would integrate x So in our case, that would be, how's x going to vary? X is going to start here and here, so that looks like it's going to go from minus 2 to 2 of x times dA, which is 1 minus x squared over 4 dx. So let's see if I can pull this off. So the first term is just x, so when I integrate that, it should be x squared over 2. The second term is minus x cubed over 4, which will be x4 over 16. And you'll evaluate the whole thing from minus 2 to 2.
Did you say that the second term is x cubed over 4, sir?
Right. If I multiply x through all these terms, I should get x and then x cubed over 4. And then I integrate those. Hopefully I get that. So we're going to need to evaluate that. It'll take a minute to do. Let's see, I got 4. What's that going to be? That's 2. 2. When I evaluated this at 2, I got 3. Did you guys get 3? I just did the upper limit. I got 4 over 2. That's 2. And then this is 6. No, I get 1. You guys get 1?
Yeah.
Okay, so that's 1. Now let's do the minus 2 limit. I think you get 1 again, don't you?
Mm-hmm.
So you get 0? That's not right. Something's not right. What do we do wrong?
I got 0.
Yeah, it can't be 0. The area can't be 0, obviously.
Did you evaluate that second term at -2?
I thought I did.
What would make things easier is when you go back up to your interval from -2 to 2, so the term above.
Yeah.
If you're integrating over an area, if it's like a negative value to that positive value, you can just factor out a 2 and then go from 0 to 2.
Yeah, I'm just wondering why it doesn't work. Why don't I get the right answer? That's interesting. What did I do wrong? Oh, that's no good. So what did you say, Mr. Jones? Is there something I forgot from my elementary integral calculus?
And not necessarily, but it'd make it like slightly easier. And there could have been a sign error somewhere, some error in algebra.
I don't see that. It looks like the answer should be 2.
Maybe we should just try it the other way. The d
I guess I wouldn't have a negative integral, right? I would be going from 0 to 1. Yeah, I don't know why that's not working. Because I like you said, I could have integrated from 0 to 2 and just multiplied it by 2, right? That would have given me the same area. But this has the moment involved. Well, I'm stumped. What do you guys think? That's a pretty...
I think just because it is on both sides of the y-axis, so you got a negative and a positive, it just kind of messes it up as far as trying to find the area.
You'd think we would have been able to figure that out. Oh. Wait a minute. I did the x-axis. I'm supposed to be finding the y-axis. Maybe that does make sense now. Because this would be 0, and that would tell me that my x-coordinate would end up at 0.
Oh.
Which is what I want. So, oops. So let's finish this, even though this is kind of a duh. That part would be 0. I didn't integrate the area, so I should have done that too. So if I integrate just dA, right, that'll tell me the area. This is just that part here. I guess it's Monday morning and my brain is not working well. So in this case, I would have, that would be x minus x cubed divided by 12. And let's evaluate that from 0, from minus 2 to 2. So I think now because they're odd, it'll work out. So we get, let's see, so the first one would be, that's 2 minus 8 over 12. And then minus negative 2 minus negative 8 over 12. A lot of negatives. What'd you get?
8 over
3. 8 over 3? 8 over 3. That seems reasonable. You guys get that? You say 3?
Mm-hmm.
Yep, 8 over 3. I got the same thing. So that's the area. Good, we got a positive number. And of course then, if we want to calculate the x-centroid, we would have this divided by the area. And of course we computed the numerator to be 0, so we get 0, which is the big surprise. We already knew that going in, so I just calculated the wrong one. So now I need to calculate what's the distance to the y centroid. So I need to calculate this term. So what's the distance to the y centroid? It's going to be whatever the height y is divided by 2, right? So I'll have a 1/2, and I'll have the integral from -2 to 2 of 1 minus x squared over 4, and then dA, which is also 1 minus x squared over 4. Okay? That's going to take me a little bit of time to do up here. I'm slow, so I'm just going to multiply it through. So I'm going to have 1 minus x squared over 4, and then minus x squared over 4, and then plus x to the 4th over 16. You guys see that? I do that right? Now I have to integrate that. I've taken up too much space. Let me get another piece of paper here. Maybe I can squeeze it in over here. So let's bring this over here. So I'm going to have 1/2 the integral from -2 to 2. Let's see what this is going to be. So I've got 1, that's just x. Oops. We've got 2 of these, so that's really minus 2x squared, right? That's going to be minus 2x cubed over 3. And then this last one will be plus x to the 5th over, what is that, 80? And let's evaluate that from -2 to 2. So what's that going to be equal to?
1.06, 1.07.
What'd you get?
1.07.
1.07? Did you get the 1/2 in front too? So the final value for y bar would be this value, 1.07 meters, divided by the area, which is 8/3. That was meters squared. So what do you get? .4. You guys get that? Oh, I got .401. That was a long trip. That's pretty close. Hey, sorry about that. Kind of got off to a rough start. These things are harder to do on the board than I thought, from a calculation point of view. Any questions before we move on?